Now we're going to start talking about first-order logic, which extends propositional logic, so that we can talk about things. In propositional logic, all we had were variables that stood, not for things in the world or even quantities, but just facts, Boolean statements that might or might not be true about the world, like whether it's raining, or greater than 67 degrees. But you couldn't have variables that stood for tables or books, or the temperature, or anything like that. And as it turns out, that's an enormously limiting kind of representation. For example, the Minesweeper game, in prepositional logic for cell 3, 4. We have to write landmine 3, 4 to number 1, 2, 3, etc. It's very difficult to express this large domain with prepositional logic. The big difference between propositional logic and first-order logic is that we can talk about things. And so there's a new kind of syntactic element called a term. And the term, as we'll see when we do the semantics, is a name for a thing. It's an expression that somehow names a thing in the world. There are three kinds of terms. There are constant symbols. They are names like Fred or Japan or Bacterium 39. Those are symbols that, in the context of an interpretation, name a particular thing. Then there are variables, which are not really syntactically differentiated from constant symbols. We'll use capital letters to start constant symbols, think of them as proper names, and lowercase letters for term variables. It's important to note, though, that this convention is not standard, and in some logic contexts, such as the programming language Prolog, they adopt the exact opposite convention. The last kind of term is a function symbol, applied to one or more terms. We'll use lowercase for function symbols as well. So another way to make a name for something is to say something like fx. If f is a function, you can give it a term, and then f(x) names something. So, you might have mother of John, or fx. These three kinds of terms are our ways to name things in the world. Atom is the smallest true or false expression. It always returns true or false. The first kind of atom is predicate. A predicate symbol is applied to zero or more terms. Predicate symbols stand for relations, so we might have things like teacher, Jerry, you, or sister, Jane, Joan. Teacher and sister are predicate symbols, Jerry, you, Jane, and Joan are terms. Another kind of atom is an equal relationship. It contains term equal term. For example, radius, Earth, equals 6,400 kilometer. In propositional logic we had sentences. Now, in first-order logic it's a little bit more complicated, but not a lot. So what's a sentence? First-order logic sentence contain with atom, complex sentence. So you can make complex sentences out of other sentences using and or, not, implies, equivalence, and parentheses, just as before in propositional logic. All that basic connective structure is still the same. The complex sentence can be used with logic quantifier. For all and there exists. A universal quantification is a type of quantifier, a logical constant which is interpreted as given any or for all. It expresses that a propositional function can be satisfied by every member of a domain of discourse. The universal quantification of a predicate Px is the proposition Px is true for all values of x in the universe of discourse. For all x human, x, imply mammal, x, it means that if every x is human then x is also a mammal. We always use universal quantifier with the implication. The common mistake is to use and as a main connective. For example, for all x human, x, and mammal, x. This means that everything is a human and everything is a mammal. X is a laptop, not a human, and a laptop is not a mammal. An existential quantification is a type of quantifier, a logical constant which is interpreted as there exists, there is at least one, or for some. The existential quantification of a predicate Px is the proposition there exists an x in the universe of discourse such that Px is true. We always use existential quantifier with logical and. For example, for some x human, x, and male, x. This means that there are some x who's a human and a male. Not every x is a human and a male. The existential quantifier is a disjunction of instantiation of all variable of x. For example, for some x human, x, and male, x. This means human, Jerry, and male, Jerry, or human, Jing, and male, Jing, or human, laptop, and male, laptop. Or etc. The common mistake is to use implication as a main connective. For example, some pig can fly. The sentence is for all x pig, x, imply fly, x. The problem is something not a pig can fly. Such as pig, laptop, imply fly, laptop, is true. The properties of quantifier. For all x for all y is the same as for all y for all x.